Okay, a little review. These should be familiar terms, I hope. Kingdom Animalia, eukaryotic creatures. What's eukaryotic mean? Judah?
Eukaryotic cells, so like they have membrane-bound organelles.
Yeah, membrane-bound organelles and a nucleus. Multicellular with cell differentiation. What's cell differentiation? Luisa?
Like cells with specific drugs, like a tissue cell or a blood cell.
Yeah, so we have an initial zygote. Multicellular creatures need a way for that cell to turn into all the various lines of cells that we need for an organized multicellular creature. So nerve cells, bone cells, muscle cells, cells that lack cell walls. That's pretty straightforward. Heterotrophic. What's heterotrophic? Let's do raised hands here. Elijah?
It means they don't produce their own energy, they get it from somewhere else.
Okay, that's right. They get their energy from other creatures. They consume others, eating others. And then motile means? Lena? Able to move. And it's the opposite of, what's that opposing term? Like the sponges are, the corals are, Alice?
I was going to say stationary, but...
Sessile. S-E-S-S-I-L-E, sessile. That's the opposite of motile. Okay, so phylum Chordata, a little review here. These are the creatures you've been studying. A lot of invertebrates. The sponges, porifera, the cnidarians, the jellyfish, and other stinging celled creatures, sea anemones, the annelids, the segmented worms, like the earthworms and leeches. We skipped over the platyhelminths and the nematodes, which are two other groups of worms. Phylum Mollusca, the cephalopods and gastropods, and the bivalves. Phylum Arthropoda, which you guys know really well. All of those different classes of segmented exoskeleton creatures. And then lastly, phylum Chordata, with a couple of kind of weird non-vertebrate members. Computer, be nice. Not to be nice today. Okay. All right, guys, we are going to change gears then. I'm going to skip ahead here and turn on the lights. We're just going to jump into class Aves. I wanted to highlight a couple of things about the invertebrates and vertebrates. You know that by far invertebrates are in much greater abundance. If you were to look at a pie chart, about 2/3 of the pie chart, maybe 3/4, would be insects. If all the creatures in the world, of all the animals in the world, about 2/3, 3/4 would be insects, and the vertebrates would be a very small sliver. And so we're getting into that small sliver now, and that's the sliver we know the most about. And so to do this, I'm going to go ahead and just turn on the lights, and we're going to look at some birds that I brought, because my overhead's not cooperating with me today. We'll get that ironed out tomorrow. Sorry for the lights. I've got some friends who live outside of town, and they have windows that are very attractive to birds. And so they give me birds periodically, and I freeze them, and then we look at them at home, and eventually hoping to taxidermy them and turn them into study skins. Like Dr. Wilson has a growing collection at NSA. An NSA student a few years ago started a collection of bird study skins, and so they have a little bit of a museum there now. And so we're going to use these birds, and I'm going to just talk generally about these birds, and I'll just point out features as we go. So we'll start talking here about general morphology, and I'm going to perch right about here. The puns are never intentional. I'm just not quite that thoughtful enough, but sometimes they happen in English. So this is class Aves, guys, and we have two members of class Aves. The first one is one that's a really common migrant right now. These birds, you may have heard them in your yard. They are migrating through by the thousands. This is a white-crowned sparrow. Notice that black and white crown, striking, that kind of peach pink colored bill. Those are key field marks for the white-crowned sparrow. I'll come down the aisle here in a moment, show that off to you guys a little bit more. So let's talk about key features of general morphology. What does morphology mean? Remember that term? Morph. What does it mean to morph? Yeah, so think like Star Trek, some shapeshifter, right? To morph is to change shape. So morphology means general shape. So that's what, when we talk about a group of creatures, you might have seen in my videos, I talked about general morphology. That's one of the things I want you guys to leave with is an impression of each of these phyla, and in the case of vertebrates, an impression for each class and group as well. And so we're going to talk about the general morphology or general shape of birds today. So this is a white-crowned sparrow, and this big bird here, not an adult, surprisingly. Bird, only a juvenile bird would decide to slam into a window attempting to kill someone's chickens. Maybe not just
Have chickens inside. Oh.
This is a juvenile red-tailed hawk.
That's pretty.
That's in absolutely virtually perfect condition. I'm really excited about this one. And so I'm going to walk around and show it off to you guys here a little bit. I want to notice a couple of key features and key differences between these birds too. And so they're obviously both birds. What keys you into that? How do you know they're both birds? Judah?
They have feathers.
They have feathers. That's a pretty good one. What else, Solomon?
They have beaks, but not like octopus.
Not like octopus. Good, I like that reference. They also have beaks unlike what other creatures' beaks? What other creatures have beaks that we studied? What's that? What's another creature we studied that has a beak? Yeah, so the cephalopods and another group of vertebrates have beaks too. The reptilians, which reptiles have beaks? Yeah, turtles have beaks, right? And so we actually, bill and beak are kind of used interchangeably, depending on what bird you're talking about. Usually if you're talking about a duck, you'd say bill. If you're talking about a toucan, you usually say a beak. All right, so notice they have these keratinized beaks. Keratin, same stuff your hair is made of, same stuff your epidermis of your skin layer is made of, same stuff that reptile scales are made of. So they have a keratinized beak. And they also have keratinized scaly legs. So I'll show you close-ups of keratinized. And I'm fine with you guys handling this. If you want to look at it and then go wash your hands, you may. If you don't want to, that's fine, Lily. You don't have to. Would you guys like to? Hold it by the body. Keep your hands away from the keratinized parts or the bloody parts, right? The talons and the beak. And this, obviously a raptor. So this is a red-tailed hawk. It's a juvenile red-tailed hawk. So wings and feathers. So feathered wings, that's a key characteristic of Aves. What else? What do you think that you see right now? Or maybe something you already know about birds. What's another key characteristic of class Aves? Yeah, after you handle it, just go scrub up well, or go to the sanitizer. We're all trained well now. So just be very gentle with that little one. What are some other things you guys know about birds? Yeah.
The hollow bones.
Okay, so that's a good characteristic. Birds tend to have semi-hollow bones. I like to think of it kind of like roofing struts, where they're not completely hollow. They actually have these engineered struts that frame the inside of the bone that's mostly hollow. And let's keep passing this one back that way, if you don't mind, Alex, just so everyone can get a chance here. Yeah. So semi-hollow bones.
Here, let me
That's
see.
a good one.
I'm not-
Why would birds have semi-hollow bones? What's
Turn it
the
a little bit.
advantage?
Turn it around.
Easier to get off the ground.
Yeah.
So they're not as heavy. That's exactly right.
Should,
All
on the
birds-
underside.
Do all birds have hollow bones? I know, right? Yeah, we should.
Oh, it's pretty sweet.
Do you want the
Super
dead
dense
bird?
bones. Yeah, flightless birds have dense
I
bones.
get that one first.
Kind of interesting. That's a problem for evolutionists because if the birds evolved flightlessness, what's the chance of them simultaneously evolving dense, non-hollow bones? Super low. Right, so most flighted birds have hollow bones, and most flightless birds have very dense bones, like emperor penguin, like the cassowary. I got a photo of the cassowary I'll be showing you tomorrow, which is an interesting flightless bird from Australia and Papua New Guinea. So we've got two things so far, guys. So in your notes, guys, hey guys, bring it down. Keep enjoying the bird, but listen. So key characteristics of Aves. And because this group is so well known to you, this list is going to be far more common sense than a lot of the other groups we've studied. Right? So we have feathered wings. Definitive characteristic. We often have hollow bones. We have keratinized beak / leg and foot scales. They're right out of the freezer, so just so you know, they haven't been thawing. Based on what you know about birds, what are some other characteristics? Well, how do we classify vertebrates? How do we classify organisms? Think about it. I need a taxidermy him in like a perching position and put him on my shoulder. Walk around class.
You'll be awesome. Doesn't have a pipe.
Or I need a terrible. Does anyone disbelieve me that this is a red-tailed hawk? It's a juvenile. It hasn't gotten its red tail yet. So just because you see a hawk and it doesn't have a red tail, if it's spring or summer, it could be a first-year bird. And they won't get that red tail until the following year. Yeah, why?
Aren't our red-tailed hawks a little bit smaller?
They're pretty good size hawks. They're some of the biggest around here. There's another one that comes in the summer called Swainson's hawk. It's almost identical in shape. It's a little bit smaller. And then there's another one that comes in the winter from Arctic Canada and Alaska. It breeds on the tundra. It spends the winter here. And that one is called the rough-legged hawk. And the only way you can tell them apart diagnostically, you can tell by some feather patterns. But the best way to tell is that a rough-legged hawk actually has feathers all the way down just to the tops of his talons. Called rough-legged for that reason. So they're really beautiful if you get a close-up look at their legs. So what else do you know about classifying vertebrates? What other things do we ask? Remember, we ask creatures questions. The red-tailed hawk comes over, and you say, "Hello, sir. Sorry you slammed into the window. Hopefully you can still answer my questions." And so you ask him, what kind of question do you ask him? Sydney?
How do you get your energy?
How do you get your energy, man? He's going to say,
Nothing. He's
What's
dead.
that?
He's dead.
How do I have any energy? Look at me. No, he's gonna say, I kill things and eat them, especially small furry things. That's how I get my energy, right? And so he's a heterotroph. What other questions might you ask him to distinguish between this group and other vertebrates? Yeah.
Are you prokaryotic or eukaryotic?
Okay, so he would say, hello, look how many cells I'm made of, right? So that would, how about other vertebrate characteristics? Well, we didn't get to talk about this. And so think about internal anatomy, think about body systems, think about differences between fish, amphibians, and reptiles, and now the birds. And so we're going to be doing a little comparative anatomy here for the next couple weeks. Yeah.
Maybe you lay eggs and you do like live birth.
That's a great one, right? So this creature is oviparous. This is an oviparous creature. By definition, they lay these calcium carbonate eggs. Calcium carbonate shelled eggs. So remember, oviparous is one of 3 different ways of giving birth for vertebrates. Oviparous means egg laying. What are the other 2 strategies? There's oviparous. Yeah. Viviparous. There's lots of V's. What's viviparous?
When they're born alive.
Yeah, so that's live birth. Good. Viviparous is live birth. And then the last one, the real mouthful, ovoviviparous. Right? That's when they actually have an egg that hatches inside them, and so it appears to be a live birth. Lots of sharks do that. It's really bizarre.
Oh.
And sharks do all kinds of terrible things to their siblings as well.
Oh, yeah.
Right? Sharks cannibalize their siblings inside the mom, oftentimes. So that's one of the downsides to being ovoviviparous. Yeah, it's pretty violent upbringing there. Okay. Toothless bill. Did we put that up here? We said keratinized beak. I'll add to that and just say toothless bill. How about their hearts? Did you guys pick up anything? Remember anything about reptile versus fish hearts? That kind of, yeah.
Cold-blooded versus warm-blooded.
Hey, that's a great one. Yeah. Are these guys cold-blooded or warm-blooded? Yeah, they are warm-blooded. So what's the code word for that, Si?
Oh, I was gonna add another key characteristic.
Okay. So what do we call warm-bloodedness? What's the fancy science jargon for that? Endothermic. That's endothermic. That means they produce enough heat during cellular respiration and other processes, they actually can maintain an internal body temperature. Just like mammals, like us. We actually get sick, our bodies won't function correctly. These cellular processes won't work if we don't stay right around 98.6. Birds is slightly higher. And so if they get too cold or too warm, that can cause serious distress. Si, you got another one for us?
Oh yeah, I was gonna say, I think open system or closed system, like with their blood.
Yeah, so closed circulatory system. Yes. And we did look at some invertebrate groups that had open circulatory systems. So yeah, vertebrates have a closed circulatory system, and along with that, a 4-chambered heart. That's the last one. 4-chambered heart. Reptiles have a 3-chambered heart. Fish have a 2-chambered heart. And so more chambers means more efficient oxygen dispersal to all the cells. And so, yeah.
How many chambers do we have?
We have 4. So mammals and birds have 4. And why? Why do you think mammals and birds, why do they need more efficient oxygen transfer, Theo?
Well, it makes sense for birds because they're flying up in the air. And so, they need all that air to go out through because they're using a lot of energy.
Bingo. Just high demands as far as energy goes. Flight is incredibly energy intensive process. So 4-chambered heart makes a lot of sense. It also happens to be that creatures with 4-chambered hearts are the ones that are endothermic, right? And so they have a mechanism for keeping their blood warm, and it's double circulation, right? we breathe in air. That blood comes to our alveoli in our lungs, picks up the oxygen, goes back to the heart, and then gets pumped throughout our whole body. Then comes back, gets pumped to the lungs again. So we have a 2-cycle respiration process. Fish only have a 1-cycle respiration process. They have these tiny little hearts, these tiny little 2-chambered hearts. And because they don't need to maintain heat, and also because their gills are so fragile, if their heart pumped any harder, it would actually damage the filaments of their gills. And so this closed circulatory system that we have and that birds have are really important. Another interesting feature that birds have, and it's similar to, and I'll put a star for this one. Are we going to 20 after?
25.
There's 25 of them. The birds need something else to help keep them aloft. Right? These hollow bones aren't quite enough. These feathered wings aren't quite enough. They have this other really bizarre characteristic that fish have a similar characteristic. What anatomical feature do fish have that allows them to stay at the same depth in the water column? It's this remarkable little internal balloon. They actually have an air bladder. Most bony fish have an air bladder. And if you cut open a fish after you catch it, you'll see this, it looks like a mylar balloon right beneath their backbone. That helps keep them at a constant depth. Birds actually have up to 9 of these air sacs. So they have these internal air sacs that actually will inflate and deflate. So their respiration is really different than ours. It's only one direction, and their lungs actually don't inflate or deflate. We will be looking at, we can't look at internal anatomy today. These are frozen, and the purpose is what wasn't for dissection. We might be able to do a dissection later in the week if everything comes together. We'll see. But we'll be looking at some photographs of birds and their internal anatomy here tomorrow, and you'll see the presence of these air sacs. They take up a massive amount of space, and their lungs are relatively small. And so their lungs funnel that air into these air sacs, and they're capable of controlling and manipulating the air or the expansion of each of those sacs. Really amazing. Just designed for flight. Okay. So don't inhale or exhale. Let's do a little bit of external anatomy since we have some time and all my devices are dead here. Yeah.
So how do they get oxygen if they don't
Yeah,
inhale?
is it inflate?
Oh, I said inhale, sorry.
Yeah.
They don't, yes, they do. They do inhale.
I'm thinking about how.
They don't inflate.
But what is the purpose of having lungs?
Yes.
They don't inflate or deflate. So unlike our lungs, they're rigid and they don't have a diaphragm. And so they don't inhale and exhale, but I said it again, they don't inflate or deflate. Their lungs don't inflate or deflate, but they do inhale and exhale. Thank you. Okay, let's talk external anatomy a little bit here. And just talk a little bit about feathers. So there's going to be 3 scales at which you guys need to understand anatomy of these creatures. One is internal anatomy, and we'll look at that on the slides. Another is kind of gross general anatomy, which we already talked about. The presence of the keratinized beak, the presence of the keratinized foot and legs, the feathered wings. But also we're going to talk about general names and location of feathers. So multiple types of feathers on each bird. So this is a songbird, order Passeriformes. This is the biggest group of birds on the planet, and this is the best time of year to see them. And so The spring migration is well upon us. You can see on the wing here, we have two types of feathers. The long feathers are called the primary flight feathers. So you should be able, if you see a diagram of a bird, you should know that those long ones are the primary flight feathers. The ones that are overlapping them above are called the secondaries. And every part of a bird lends itself to telling you how or why it's built. There's a saying in biology, form equals function. And that's really true with birds. You can tell right away maybe what habitat these birds live in or what kind of food they eat based on their beak, based on their wing shape, and also based on their feet. So obviously a predator with very large soaring wings. So this is a soaring hawk. Red tails are called buteos. That's the group of hawks that are part of, which include those others I mentioned. See how long the primary feathers are there? They are soaring hawks. They're the ones you see circling above, around and around and around. They're riding thermals. They try to use the wind as a way to save energy, and especially for migration. So you can see those primaries. Tail feathers serve several different purposes. What do you think? What do you think a group of tail feathers is good for?
Probably steering.
Yeah, it's a rudder. So the first thing is it's a rudder. Okay, what about in a woodpecker? What's a woodpecker do with his tail that other birds might not do? Why?
Stabilizer.
Yeah. Exactly right. He stabilizes it against a tree, pivots that tail, and then he climbs up like this. Never climbs upside down because he needs that tail to keep him from falling. And so tail feathers, they usually are called retrices. The retrices. R-T-R-I-C-E-S. Retrices. The majority of feathers on a bird look like these soft feathers on this white-crowned sparrow's belly. They aren't long and shafted like these flight feathers are. They're just smooth and almost like downy feathers. Just really soft, and all birds are just covered by thousands of these. These are called contour feathers. Really soft, almost down-like. And in fact, in a chick, down would be here before the contour feathers grow in. So these feathers are connected to the blood supply. If anyone raised chickens, or have any chicks in their house right about now? You've raised chickens before. If you look closely, when they're young, especially, those feathers are just starting to poke out. I mean, they're pretty ugly. When those feathers aren't nice and soft and outside of that little sheath, they look pretty rough. But you can see little capillaries. You can see it's kind of red at the base of those feathers. And so they are receiving nourishment during that period of time. Okay. Two other geographic, I guess this is more of like a topographic anatomy for the bird. The crown, you need to know the crown. And you need to know the nape of the neck, where a cat mom grabs her kitten, right? That's the nape. Under the base of the tail, it's going to be hard to see in the red-tailed hawk because it's so stiff. Have you ever watched birds kind of sitting and rubbing their beak through their feathers? What's that called? It's called preening. And they actually have a little gland right at the base of the tail, which is probably going to be difficult to find in this songbird. Oh, there it is. If you lift up the tail feathers just right, there's a little tiny gland here called the preen gland. And actually will dab there, just barely see a little bit of a fleshy protuberance there. It's very obvious if you plucked a bird for slaughter, very obvious that fleshy protuberance. It looks kind of weird in chickens. They actually press their bill against that gland and get the oil on their beak and then rub it to preen their feathers. And that serves a variety of functions. It has antibiotic properties, that oil, but it also has the ability to just kind of smooth and reconnect all the different bits. Not sure how close I can get up to the camera here.
I'm zoomed in pretty well.
Okay, so right about there, the preen gland, and you probably are getting a good look at those different parts of the feather as well. And if you guys have ever used a feather for any reason, you know that they're almost like a compound leaf. They are made of barbs, but the barbs have interlocking pieces as well. So if you look closely at this white-crowned sparrow, you see each feather has little tiny divisions all the way down the feather. And then those divisions are divided again. You can't see those, they're really microscopic. And that's what the bird is doing. It is preening to interlock all those barbules. What's the value of a bird making sure the feathers are aligned and connected correctly? What's a function that might be serving? Yeah.
Streamlined.
Okay, so it's going to help with flight, making it more aerodynamic. Caleb, is that what you were going to say? Okay. Theo?
Well, any like holes are gonna take up more energy.
Okay, so that you're going to lose energy both aerodynamically, but you're also going to lose heat. Yeah, so insulation as well. Yeah.
It's easier for dirt to get in, it's all like messy.
Yeah, so that's just a bird cleaning itself. Another thing often birds will do, especially game birds, they'll often take a dust bath as well. And so they'll get that dust in there under their feathers to take care of the itch. All right, guys, thanks for going with the flow today. Good to see you again.